Hello class, I keep getting emails asking about rounding with 8.4 homework. People are rounding and they're saying they are rounding correctly, but they are getting counted wrong because these numbers are off in the hundredths place. So they're right, all these digits up till here. Okay, and the problem is just about universally, the problem is multiple rounding steps. If you're rounding more than once in these problems, that's typically what the problem is. The expectations, these numbers are coming from this formula directly. You're using this formula directly, and you are hitting enter on a calculator, scientific calculator, or like I'm going to use Google, and you're only putting it in there one time. Okay, so I'm going to show you how I would put this particular problem in, and for all of these problems in the homework, and show you that we are getting these numbers that we're supposed to. Okay, so for this is the principal, the rate, how many times it's compounded, and then we want to know how much will be in there in the number of years. So I'm going to put in P is 12,000, parentheses 1 plus, okay, I'm just plugging into the formula, R over N. R is the rate, we write it as a decimal, so 0.07 divided by N annually is 1. Close that parentheses, raised to the power of, remember that's shift 6, N times T, 1 is N again, times T is 4. Alright, and when I hit enter, there is the formula, there's what it's giving me. Alright, so notice it's 55, there's 55. Alright, the interest is just taking this number and subtracting the principal. So when you get this right, just subtract the principal, and that's part B. Alright, now I'm just going to go through and just show as I go through and do this. Principal is 95, so I'm going to go in here and change that to a 9500. So that 120 becomes a 95. 1 plus, the rate is 5%, so 0.05. Compounded quarterly, so the old N that was 1 becomes 4 times and a quarter. 4 times. So I hit enter, and then there's 1158.950. So there's that number. Alright, again, same thing for interest, just subtract the principal. Alright, now with these daily ones, just make sure that you read this part up here. That daily is 360 for days. Alright, so we'll change this to 0.065. It's compounded daily, so that's 360 times. So there's my N, and then N times T, so I change that to an N. 360. Alright, and then there's 3890.698, so that 8 means change that, round that up, so I change the 69 to a 70. Alright, same thing. Suppose you have 14,000 vegetables, which these two would yield the larger amount in a year. 11% compounded monthly, or 10.93 compounded continuously. So if I take the 3 and change it to a 14 plus 1.065, let's see, it's 11%. So 0.11 compounded monthly, so that's a 12. 12 and 1 year, so T is 1. Alright, so there is 15,620. Alright, that's the 11% compounded monthly. Now remember, for continuous compounding, it's PERT, A PERT. So P, I'm going to hit Control X to get rid of that. P times E raised to the power of R times T. So R is 0.1093, that's R as a decimal, times T is 1 year. That's A PERT. So 15,616.95. The other one was 15,620, so about $3 more roughly with the compounded monthly. So that's where that's coming from. Okay. So again, it doesn't ask what the numbers were, it just asked me to compare the two. So the compounded monthly was higher. Alright, how much money should be deposited today into an account that earns 8% compounded semi-annually? Right, this is a little bit different. This one is present value formula. So here is present value formula. Alright, the present value equals the amount we want to get to. So the amount I want to get to is 12,000. Alright, divided by parentheses 1 plus R over N. R was 8%, so 0.08, divided by N. N is compounded semi-annually, so that's 2 times a year. Close. Raised to the power of it again. Anytime there's an exponent, we need parentheses or multiplication in the exponent. So N times T, so it would be 2 for N times T is 3. So there is what I get. Alright, and 83.774. Now this would round to 77. 78 is our answer. It says right here, round up to the nearest cent. We're rounding up because if we truncated, if we rounded down, this was my original deposit, and I need this extra bit on there to get there. If I took that away, I wouldn't be able to get to the 12,000. So in that case, I would have to round it up to the 78 because 77 cents would not get me there. It wouldn't be very far off, but it would be far off enough to where I wouldn't be exactly 12,000. So this one I did need to round up, but it also tells me right there, round up to the nearest cent. Alright, and then we're back to the old compound interest formula. Alright, so the old compound interest formula, it says you deposit this much, 5.5%, compound quarterly, find the future value after 1 year. So I'm back to this, P times, so 9,000 times, parentheses, 1 plus R over N, 0.055 over compound quarterly, so 4, close, raised to the power of, parentheses, 4 times 1 year, it says in part A. So there is the 30 cents, so it says 30. Alright, and then the effective annual yield. All you have to do for yield is take off P from the formula, so I'm taking away P, take away T. Alright, to do that, you're going to subtract that from 1. Okay, or subtract 1 from that. That'll give you the percent as a decimal, and then you move 2 places to the right, remember, to get a percent. So all I did there, again, just look, there's the old formula. I just took away the P, I took away T, and then after you raise it to the n power, you just subtract 1. And there's my answer, my yield as a decimal. So move it 2 places to the right, 5.614, and then round to the nearest tenth. Alright, so again, all of these can be done with just these basic formulas that we showed in the slides, and plugging these values in. So here's another one, just round it to the nearest tenth of a percent, the yield. So 10% was my rate, so 0.1, and it's compounded semi-annually, so that's a 2, and this would also be a 2. So 0.1025, move it 2 places, round to the nearest tenth. So if I move it 2 places, the 2 would be in the tenths place, so the 5 means round it up to the 3. And this one's having me determine yield for 2 different accounts. So again, it's just a 1 plus. The decimal here is 8.5%, so that would be 0.085. And it's compounded monthly, so that's 12 and 12. Alright, and there it is, a decimal, so move it 2 places, so 8.8, let's see, they want it 2 decimal places this time, so 8.839, so 8.84, and then 8.75%, so sticking an extra 7 in there, compounded annually, so take that back down to a 1, and that down to a 1. And there's our 0.0875. Alright, when it's only compounded once a year. That is the yield. The yield is the rate. So we see this is a little bit higher because of the compounding. All right, and then we start getting into the word problems. So $4,000 is our value for P. 5.5 is our value for R. N is 12. It's compounded monthly. And then 21st birthday. Okay. So 21 years later. So we're going to plug in. We're going to have a P again. So 4,000. Amount time of the birth. The rate was 5.5%. Compounded monthly. So 12. Alright, and then 12 times 21 years. And then we'll take away the -1. It's not yield anymore. So there's our 12,662.63. I want it to round to the nearest dollar. So 62.6. We'll round up to 63. Alright, same thing. Person A, $2,600, 5% compounded once a year. This one's compounded monthly, so we just plug in the two values. So 2,600, 5%, so take away that. Compounded once a year, so take away the 12s. After 1 year, so after 1 year, this will be 1. N times T. So there's how much person 1 will have, the 2,600. Okay. Make a little snippet of that. Alright, and then how much will person B have? They're proposing 2,200. And it pays 6%, so it pays a higher percentage, and it's compounded monthly. So there's how much person 2 will have, right? And then how much more will person 1 have than 2? Well, we see 1 had this amount. So take that 2730 and subtract this amount, and round it to the nearest dollar. So 2336. 2730 minus 26, so 394, where that's coming from. And then 5 years later. Okay, so this is person A, and I just made a new tab, copied and pasted. That's person B. So in 5 years, we're going to do, this is 2,600, 1 plus 5. Again, it's only compounded once a year, or there we go, 1, and then this is 5 years, so N times T. Okay, so again, P 1 plus R over N raised to the N times T power. Alright, so there's that one, and then this is the second person, 2,200. So all I gotta do is change this to a 5. Okay, so there's person 2, compound interest. There's person 1. So I can just take these two numbers, create a third tab for the difference. So this was the first person, 3318. That's what that would round to the whole. Alright. Person's 2, 2967. That's below a 5, so that would round to 2967. So I just subtract those two, 351. Alright. And then they want to know after 20 years. So now that I've changed, this is person A, this is person B. Now all I have to do is just change the time to 20 for both of these. Alright, so person B, 7282. Person A, 6898. So person B has 7282 minus person A now has the least, 6899. So there is the 383. Alright, so we're depositing this much into an account. It pays 8% interest, compounded semi-annually. After 2 years, the interest rate bumps up, and the number of compounding times in a year bumps up. So what's the value after 4 years? So that's 2 at this, and then 2 more at this. So here's the first 2 years, 4,000. 1 plus 0.08 divided by 2, because it's semi-annually, so n is 2. Raised to the 2 for semi-annually, n times 2 for t, 2 years. Alright, so plug all that in, I get 4679.43-ish. It says around the nearest dollar, so we're grabbing this number and then taking that 4679 and then plugging into the next one is 0.0852 4 times per year, compounded quarterly. So 4, and then there's the last 2 years. And so we get 55.38.34 for the second round, the second part. Alright, and then for this one, in 1625, an explorer convinced a group of indigenous peoples to sell them an island for $25. If those indigenous peoples had put the $25 into a bank, paying 7%, how much would the investment be worth in 2001? The interest compounded these two amounts. So let's plug in the $25. 1 plus the rate is 7%, so 0.07. Compounded monthly, so 12, and then 12 is the number of times it's compounded per year, times how many years are they doing it. So you'll need another parentheses here, or you can work this out ahead of time. 2001 minus 1625 is the number of years. You type all that in, and it gives us the answer in scientific notation because it's such a big number. But e to the 12th, that means that decimal point is 12 places to the right. So 6242528 and some change. This is the only one that has that, the 6242528. So this is the answer. Okay, D. And then how much would it be if it was compounded continuously? Remember, that's P times E raised to the RT power. It's raised to the RT power. So the rate was 7% R times T, and again T was, like I said, you can work this out ahead of time. Just subtract 2016.25 beforehand, and then you can just put that number in for T. Alright, or you can just plug it in there like that manually. Alright, this is 6.738. Again, the decimal place is 12 places to the right, so that's going to be this guy right here. Okay. There's the decimal place, 12 places. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So again, it's given to me in scientific notation, but I can match up the digits there. But it's giving me that. Alright, same thing as before. We had the future value formula. This was this guy? No, this guy. And we want 80,000 in 9 years. So we take the amount we want, the 80,000. We divide by parentheses. 1 plus R is 7%. So 0.07. N is semi-annually, so N is 2. Shift 6 raised to the parentheses. N times T, so N is 2 times T is 9. Alright, and there's the up to the nearest dollar, so 6.8, round this up, so it's 6.9. So that's coming from, again, with this, if we round these down, or if we follow the regular rules for rounding and we round down, we won't get to our goal. We round up to make sure we get to our goal no matter what. Alright, and then yield. Remember, yield is taking the compound interest formula and leaving off P and leaving off T, and then just writing in whatever's left. So the account pays 5.2% compounded daily. Alright, so 5.2%, so 5.2 compounded daily. Remember, daily, they say use 360 right here. So 360, and there's a 360. And then that's, oops, I forgot to do the -1. -1, and then there's the decimal. So to get a percent, we move over 1, 2 places, round it to 2 decimal places. So 5.337 would round to 5.34 for yield. Alright, now, that's doing this entire homework set via the calculator on Google. Like I said, I would rather you guys just make the spreadsheet. You're going to have to make a spreadsheet for this function, or for this budget project by the end of the semester. So I would go ahead and do it. The amount of money to see, that's the future value. Let's see, there it is. So $9,000. So I'll just plug in. This was already made while I was making the video. 9,000 pays 5.5%. It's compounded quarterly, so N is 4, and the future value after 1 year. All right, there's the future value, 955.30. All right, it only gives tenths of it a 0 after that. And then there's the yield. It even gives the yield rounded to the nearest tenth. So I would strongly encourage you guys to do, follow along with that video for the Chapter 8 intro, where I did a bunch of these formulas in Excel.